In this lecture, we're going to talk about object-oriented design. I think this is a really exciting point in the semester because we've been using Java all semester, and we know that Java is an object-oriented programming language, but we really haven't appreciated what that meant or seen like the full power of object-oriented programming. And so this is the beginning of our journey into object-oriented design. It's something that we'll be focused on for the rest of the semester, and also something that you'll focus on in the next Java course if you take Computer Science 240 at some time in the future. Our goal in this first lecture is to understand that object-oriented design can be used to create your own custom data type. So let's talk a little bit about object-oriented design. We know that Java is a programming language that was specifically created using object-oriented design. Using this approach, when a programmer starts reading through a problem description, they naturally start identifying the abstract data types that are required to solve that particular problem. An abstract data type is just an idea for a custom data type that can be used somewhere in your program. So abstract data types are written just in regular English. They're not like a fancy programming thing. It's just like jotting down your ideas. So it's just creating a plan for a data type that you want to create in your code. But the abstract data type is just the idea, not the actual code. So the plans that you create for these data types are going to have two different components to them. They're going to have data values, which will be the information that that particular new data type bundles together. And then they'll also have operations that are legal to perform using that new data type. And so far this semester, when we've been looking at programming descriptions, we've been thinking about kind of like the nuts and boltsy kind of things, like should this have a conditional statement, or how many loops do I need, or should I use an array or an array list, or just separate variables. At this point in the semester, we're shifting to kind of like higher level design, where we're going to be thinking about more of the complex. How does the data relate to each other, and what should be grouped together to create a new data type? And of course, we'll still be using all the nuts and bolts, conditional statements, input and output, variables, repetition statements, and of course, methods. Whenever we're in the planning phase for a project, we'll be thinking about each of the abstract data types. And in Java, those are naturally turned into a programming solution using a mechanism called a class. A class is just the way that Java allows us to define a data type. Inside a class, it tells Java how to make an object or a variable of that new data type that you have. And it also specifies which methods or operations are available on that kind of data. It's really important to realize that when you're defining a class, it doesn't actually initiate any action in the program. It just creates the possibility of defining objects of that new data type. And that should seem pretty intuitive. We know that the standard library, the Java API, has like thousands of different data types in it, right? But just having that library available to us doesn't magically make our program do anything. We have to be able to declare variables from those data types and then use those to call methods to actually make stuff happen in our program. So we'll be writing our own classes in this part of the course. And once a class is complete, then we'll be able to define variables of that new data type. And we'll call those variables objects. An object is just it's a variable whose data type is defined by a class. And we'll be able to use the objects that we define to call the methods that are available to our data type. And again, we've been using classes all semester long. They're part of the API. But the kind of new step that we're taking here is we're going to not be just constrained to those data types that are part of the API. We'll also be able to do our own data types, which I think is pretty cool. So you might wonder, like, what goes into this object-oriented planning? Dr. Anwalt said we're going to be like looking at the problem description. We'll be thinking in this object-oriented way. What exactly does that look like? So again, you're going to go into a lot more detail about how to read a problem description and pull out natural data types if you go on in the computer science course sequence and take the next course, which is called Object-Oriented Analysis and Design. So you can imagine that's pretty heavy on this component of programming. We're just going to get like a little taste for it in Computer Science 220. And then again, you'll develop your expertise later. But basically, when you're looking at a problem description, you're looking for these data types that would be part of the solution. So when you're looking for the data type, you're thinking about, is there a group of information that models a particular thing in the program description? Like, suppose that our goal is to develop a system that tracks information about a student at a university. And it's supposed to include their last name, their first name, their GPA, how many credits they earned. So one particular data type that might be possible in that particular solution would be something that models the student, something that bundles together all of that information about a single student to create this custom data type. Has all of those different components, the last name, first name, GPA, and total credits. So the new data type has all the essential information about a single student and would also have the methods in it that would allow us to manipulate that information to do particular operations with it. We've seen that the Java API has lots of useful classes like string and array list, and we might hope that there was already a class in the Java API that modeled students. But the reality is the people who made the standard library can't have possibly anticipated every data need that we might have in our program. They don't have any possible way of guessing that you might need a student type. And even if they could predict that you needed a student data type, they wouldn't know what kind of custom information you wanted to store. We're thinking about storing last name, first name, credits earned, and GPA. But that's just like the tip of the iceberg in terms of data that you could store about a student in a university. So they couldn't possibly guess that we only wanted that data and not additional data, and so on. So we can't always rely on the Java API to define data types for all of our purposes. Thankfully, Java has this mechanism in it that allows us to create our own data types. So before we start to create our custom data type for students, we have to learn a little bit about what the project organization is going to look like. So from this point forward in the semester, when we're writing programs, they're usually going to involve two different steps. The first one is identifying all the custom data types that we need for our project. And for every custom data type we identify, we're going to need to write a data type, a class, for each of those data types. And we'll have one .java file for each class that we create. Then in addition to the files for all of our individual classes, we'll have a separate file that is our main class. That's the part that makes all the action happen. And so that'll be where we declare objects and where we call the methods that are part of the classes that we write. So the projects that we're going to create from this point forward are going to be multi-file projects. They won't be just a single main like we've been doing so far this semester. So we're going to be working through an example, creating a student data type for the next couple days. The information about the student data type will be in a file called student.java. And then we're going to have a separate main file that declares objects of the student type and also calls the methods on those. And that'll be our main.java file. And together, those two files will create our project solution.